morning, everybody. My name is Juan Nieto. I'm from ETH, and we were leading this project Flourish. And Flourish, it was about developing robotics technology for agriculture. So the consortium was formed by all these universities that you see there, and the end users. So we have crop science from ETH, and also Assam from Italy. So let me start with the motivation. So why do we want to do robotics for agriculture? I think we are all aware that current practices are not sustainable. So we know that we are using too much natural resources, too many chemical products, and one of the problems is that farmers are doing that because they don't have enough information about what is going on. And then as a result of that, we have been increasing the size of the machines in the last years and applying what we call one-fits-all solutions. So we use the same type of solution for all different type of farm, for all different type of seasons. And this is where robotics can help, and I hope our story serves also as a motivation for you to continue building on top of this. Robots can help because they can get high-resolution maps. They can be in the right place at the right time. They can work 24 hours, and then we don't need to have people doing that type of task that we see there. So, what is Flourish? Flourish, the main objective of Flourish is to develop flexible robotics technology in order to enable precision agriculture. How did we do it? So, the way we thought about the project, it was by having a multi-robot approach where we are combining aerial sampling, so aerial mapping with a drone that is flexible and we can send whenever we want, and it's also cheap, with a ground robot that is slower and more expensive, but it can actually do intervention. So in this project, we have two main use cases. On one hand, we have the automated mechanical treatment of weeds, and the main focus was always on weeds, because we know that if we can identify them, then we can do a lot of other things or identify a lot of other problems with the main crop. And the second use case, it was to try to build maps in order to do inference about nitrogen fertilization. And this kind of cartoon is just to illustrate the main concept. So the main idea is that you send a flying robot, it will do inspection, it will find some problems, for example, some weeds, and then this information is going to be sent to the database, to the farmer, where it will also be connected to the ground robot. And then we are going to send the ground robot, which is going to intervene and act accordingly. So this is a small video that just hopefully puts a picture in those cartoons. It was done for a TV channel in Germany, and this is a small summary of that. But what I want to show here to highlight the main idea is just to show you the size of the robot. The robot was actually very slow, and it was too heavy. It's not the right robot to do, so hopefully the next generation is more suitable for agriculture, but it has all the features that we actually need for perception and intervention. So let me go forward just to show you some examples of the classification. So this is one of the classifications, for example, from the UAV, and this is all the perception from the UGV. But I will show you a bit more details now in few minutes. And finally, you can see here the mechanism that we have in order to do intervention. In this case, we are using stamping. We also have spraying, so we have two different mechanisms to develop in the same robot. So I don't want you to remember anything from here, but I just want to highlight that we actually developed technology for perception, for UAV, for the UGV, also for navigation, for the ground intervention, and we did a lot of actually interaction and integration. I think that was for me, as we were leading the project, and for me the main challenge was all the integration that we had to do, particularly when you have multi-robot systems with different partners, and perception, navigation is really hard. So And now I just want to highlight some of the main outcomes of the different components. So the main objective of the UAV perception, it was to build this type of maps with crops and width. And for that, so we were using RGB camera, and what you see here on the top left, let me use the pointer. On the top left is a 3D map of the main of the farm, which was built with RGB images. And then once you have this 3D map plus the classification, then you can build this kind of spatial temporal maps that we can give to the farm, and then he can do, or any system, to do inference about the particular treatment. So for the UGV, we also developed a perception algorithm. The main task, it was classification. It was to try to classify weeds from main crop. And the main challenge here, so I will try to focus in the main challenge, hoping that people get inspired for the next Flourish project. The main challenge is the crop variation here, because the crops are changing all the time. So you can train a classifier, you can train machine learning, and then it will be good. But then it will change from season to season, from farm to farm. So we developed a technique for this where we could train every morning the robot. So it was very fast, and only with one small row we could retrain in order to fit the particular needs for this season. In terms of the navigation, it was also hard because you will see the crops are actually very small. So the best time to actually treat the weeds is in a very early stage. And we are talking about, this is sugar beets, so we are talking about 2-centimeter crops. And you saw the size of the robot that we have. So trying to navigate between 2-centimeter crops and making sure that we don't run on top of the main crop, it was actually very challenging. So we also developed some techniques here in order to do navigation, where we estimate the position of the main rows and using half transform and Kalman filters, etc. So now, I guess this is always the nicest part to see in terms of the intervention. As I mentioned before, we have two different mechanisms, spraying and stamping. And this is the spraying. It's actually very hard to see. At the beginning, it was not very precise, but at the end of the project, we actually got it very well, and we were like in the order of 1 centimeter error. And the stamping, it was actually hard because you had to be even more precise. So, and because actually the UGV is moving, whenever you see, so the perception part will be on one side of the robot and the actuation on the other side. So you have to do tracking, and you have to do a lot of motion compensation in order to hit something that is few centimeters only. We also have an end user evaluation. This was done by Assam in Italy, where we did a demo of the whole system running. And what you see here is that first we send the drone, and then the drone identify particular spots where there were a lot of weeds. And then after that, we send the ground robot. Let me fast forward. So what you see here is the map from the UAV. And now once the UAV identifies a particular spot, it will send the ground robot, and that you see here. And we actually produce a lot of information from the end users and also from the farmers. It was a big event in Italy. And this is some of the main findings, but I'm happy to share with anybody. It's a long report. I guess one of the main worries of the farmer, it was the cost. So they were super happy with the technology. They say, well, this could be very good for them, but they didn't see that it was flexible enough for them to use. They see it as black magic, almost. And also that it could be something that is very expensive, and they will need a lot of training in order to use it. So that's one part where we need to work a lot for the future. Some of the highlights, just to finish, so we were in TV a few times, a lot of publications, workshops, etc. And with that, I just want to thank you for your attention, and hoping that our story inspire others in order to continue building this type of robotic technology for precision agriculture. So thank you very much.